Hi, this lesson is on translation of exponential functions. So first of all, what we need to know is what an exponential function is. If you look at this example right up here, f of x equals 2 to the x minus 1. If there's a variable in the exponent, then that's an exponential function. So we're going to graph this one. We're going to get some table of points and graph this. I'm going to go through it pretty quickly because they do a pretty good job in your instruction of how to do it. But basically the first step is we're going to find the value of x that makes this equal to 0. So what makes this equation equal 0? Well, that would be x equals 1. And we can check that answer. Now we're going to calculate what f of 1 is. So we're going to substitute in 1 up here for x. So 1 minus 1 is 0. 2 to the 0 is 1. Anything to the 0 power is 1. So now we can plot this point, 1, 1, and it puts it on our table as well. Now we're going to evaluate the function for 2 more points. When we substitute 0 into this, 2 to the 0 minus 1 is 2 to the negative 1, which is 1 over 2 to the positive 1. So that's just, 1/2. And then if we put in f of 2, we're going to find out that that's 2 to the first power, which is just 2. So now we can plot these points at 0, 1/2, and at 2, 2. Notice it's in the table over here. The asymptote line. Now, you've probably heard of asymptotes before, but an asymptote is an imaginary line drawn on a graph that the line of the function does not cross. It approaches it, but it never crosses it. And in this case, if I were to draw this line, it would get down here closer and closer, and as we go negative, it would get close to, but never cross 0. So the asymptote is y equals 0. And there's what a graph of our function will look like. So now we're going to look at actually what happens when we translate or move the graph left or right. We call them shifts or slides. They can go left or right. They can go up or down, depending on what we're going to add or subtract in the exponent and also on the outside of the exponent. So the first thing we're going to look at are horizontal translations. So here are some rules for horizontal translations of exponential functions. If you notice, we've got a general form up here. F of x equals b to the x minus h. Now this is just like our absolute values and square root functions. When we're in a horizontal translation, when there's a minus sign, I like to rewrite it as f of x equals b to the x minus, and then I put h in parentheses. That helps me identify whether h is positive or h is negative. So I'm going to look at the positive side first, actually. So if h is positive, that means if we have a subtraction, x minus something, so f of x equals b to the x minus 5, that is subtracting a positive 5. So we're going to shift, let me move this over, you see that? We're going to shift h units to the right. So if it's positive, we shift to the right. Now, the domain is going to be all real numbers. We can put anything we want in here for x and find something. And the range is going to be y is greater than 0. Remember that this is going to approach, but not get all the way to 0. That's why this horizontal asymptote. So the horizontal asymptote is y equals 0. So our range, or all the y values, are going to be greater than 0. They don't equal it. So those two are always related. Whatever your horizontal asymptote is, your range is going to be greater than that. Now let's look at our negative, if h is negative. So if I were to write this, f of x equals b to the x minus a negative h, well, if we simplified that, that's like b to the x plus h, right? So if we have a positive up here, that means that h is actually negative. So you've got to be careful about that. That means we're going to shift it to the left. Again, our domain are all real numbers, and our range is the same as greater than what our horizontal asymptote is. So if our asymptote, it approaches and it's y equals 0, then our range is y is greater than 0. So let's take a look at an example here. Let's determine the value of h. So we can see we've got this function right here is our parent function, 1.5 to the x. It goes right up there like this. Now over here we have g of x equals 1.5 to the x minus h, and we're trying to find out what is h. Well, if we look at this, g of x equals 1.5 to the x minus some value. Now which way did we go? If we just look at this first point here, we went 1, 2 to the right. So I know h needs to be positive. So I could rewrite this as 1.5 to the x minus a positive 2. And then that would be 1.5x minus 2. So the correct answer is 2. Even though this says minus 2, h is actually a positive 2 because that's what's inside those parentheses there. Okay, we've looked at horizontal. Now let's take a look at what happens when we have a vertical translation. If you'll notice this, f of x equals to the 0.5 to the x, and then minus 3 is on the end. It's not in the exponent. So this is going to give us a vertical translation, up or down. So we're going to look at the same thing. We're going to calculate an initial value. F of 0, 0.5 to the 0 is 1, and 1 minus 3 is a negative 2. So that's our initial value, and we're going to plot that point, 0, negative 2. Over here we have our table of values you can refer to. Then we're going to evaluate the function at 2 more points. So if we put in a negative 1, 0.5 to the negative 1, now remember if we have a negative exponent, it goes in a fraction. So that's 1 over 0.5 to the 1, and that's 1 over 1/2, which is actually 2. And 2 minus 3 is a negative 1. That one's a little confusing, but... And then f of 1, 0.5 to the 1 is 0.5 minus 3 is a negative 2.5. So now we've got 2 more points that we can graph. So we've got negative 1, and 1, negative 2.5. So again, this is called a decreasing function. You'll notice if we were to graph this, the points are going to be going down. Sometimes that's called decay. Increasing our functions are called growth, so you'll probably see that. But here is a decreasing exponential function, or a decay function. And we can see if we went like this, it's going to keep coming down, and it's probably going to be at negative 3. And here's your clue. Whatever we shift it down, that's going to be the asymptote. So y equals a negative 3. And then when we draw that line, we can see it approaches negative 3 but never crosses. So when our range is going to be y is greater than negative 3, and the domain is going to be all real numbers. Okay, let's take a look at our rules for vertical translations of exponential functions. If we have our form f of x equals b to the x plus k, then if k is negative, so another way to write that is f of x equals b to the x plus a negative k. Or it would look like b to the x minus k if we were to look at it in a regular function. So if k is negative, we're going to move k units down. The domain is all real numbers. Remember these exponential functions, all real numbers. Our range is going to be all numbers greater than k, because remember we have this asymptote at y equals k. So whatever k is, the range is going to be greater than that. So if we have f of x equals b to the x minus 2, then I could know that our asymptote is equal to negative 2, and our range is y is greater than negative 2, all those values. Let's look over here at if k is positive. Positive is just like this one right here. We're adding a positive k. So if we're going to move k units up. Domain, remember, all real numbers. Range, we're going to be greater than k, and y equals k. Those remain the same. So once you know what k is, you know most of this. So if we have let's do f of x equals b to the x plus 5, then I know that the range is y is greater than 5, and the horizontal asymptote is y equals 5. So let's look at the value of k in this example. Here we have our original function, our f of x equals 5 to the x, and then it's shifted down 5 to the x plus k, and we're trying to find out what k is. Well, the easiest one I like to use is the one right on the y-axis. So here we have this, and this is these are by 2's on this y-axis, so I'm going to go down, 1, 2, 3, 4, 5, 6, 7. So g of x is equal to 5 to the x plus a negative 7, if we want to put it in this plus. So what is the value of k? Well, the value of k is negative 7. If we were to simplify this, it would be 5 to the x minus 7. So if we're looking at multiple translations, meaning here's our parent function, f of x equals 2 to the x, and we're going to actually shift it horizontally, and we're going to shift it vertically. What can we do? Well, here's a table, and they walked you through in the lesson, and they did a good job of looking at it and walking through so you could visually see what would happen. But sometimes it's kind of hard to tell from a table what exactly is happening. So here's the table that they did. They started plotting points, -1, and we put into the original function, and then we put it into the translation function and tried to see what was happening each one. Well, I'm going to give you a different way of looking at this so we can maybe visualize it a little bit better. So I'm going to go to desmos.com and click on the graphing calculator. And I'm going to graph these right in on here so I can take a look at what it is. So our first one was y equals, because it's easier to write y than f of x, 2 to the x. Now remember, to get it in the exponent, I use that little upside down v, or the caret symbol, which is above the 6. And now I've graphed this function 2 to the x. And we notice right here at 0, 1 is the point where it crosses the y-axis here. Now we're going to do our translated function. So y equals 2 to the, now I've got to put it in parentheses so it all stays up there. And it is x plus 2, and then I shift over minus 4. You have to use your arrow keys over to get it where it wants to be. So here is our new function. And here we have, you can see, now sometimes it's a little tricky. You're like, well, where did this go? So let's take our point right here that was 0, 1. And if we look at our translation, this is a plus 2. That means we had to subtract a negative. So h is negative. So we were going to go to the left 2, 1, 2, and k is a negative 4, and we're going to go down 4. So from this point, we're going to go 1, 2, and then we're going to go, let's see, 1, 2, 3, 4. And you'll notice that's on that point right there. Whoops, not that point. That point. So you can see that that is how the graph is translated. And if we took any point, another one would be, and you see how exact, 2, 4. So we go left 1, 2, and we would go down 1, 2, 3, 4, and there's my translated function. So sometimes it helps to graph it and see what that looks like. So here's something that I want you to put in your notes. This is a way to remember vertical and horizontal translations. So our vertical translations are the form f of x equals b to the x plus k, and it gives you some shifts up, shifts down, and some examples of what those would be. If you don't, take a minute, pause the video, write this down, and it will help you remember when you're doing some of these shifts. Okay, let's take a look at some of your problems from your assignment. If we have two graphs right here, and we have y equals 2/3 to the x and 2/3 to the x minus 2, remember, if it's in the exponent, we know it's going to be a horizontal shift. So it's going to be either right or left. It's not going to be up or down. And now we have x minus 2. If I rewrite that as b to the x minus h, we notice that 2 is actually a positive 2, so we are going to translate that and shift it 2 to the right. If we notice, we look at this, we have a point here, and you notice it is 2 to the right. Every point is 2 to the right. So a function is 1/5 to the x is translated up 4 units. So we know if it's up 4 units, remember our vertical translations are of the form b to the x plus k. We don't have it in the exponent, we write something outside. So these two are in the exponent, so those are not it. Now we have to know if it's positive or negative. Well, if it goes up, then it's positive. So we have 1/5 to the x plus 4. How do you determine the range values from an equation? Now this goes back to what we talked about. Once you know k, then you can find the range and the asymptote. So in this case, we have y to the 4/5 x. Well, is anything being added to it? No, that's like a plus 0. So in this case, y is going to be, all the range values are going to be greater than 0. Here we've added 6. So we've shifted it what? Up 6. So that goes up 6 units. So that means our y values, or our range and our asymptote, are going to be up 6 units. So y is greater than 6. If you look at a table, determine the characteristics of a translated function from a table. So this one, if we have f of x is 1 and g of x is 0, which one of these are true about this g of x? I want you to pause the video and see if you can figure this out, and then come back and we'll walk through it. Okay, one of the things I want you to notice on this is from the first function to the second function, these are the y values, the output is just 1 less. I notice that each one is 1 less. And so I can tell that that is a shift down by 1. Now this last question, the domain and the range, the domain will be the same, but because we shifted the y, the range will not. And here's just another reminder. If you haven't paused this, write these down in your notes. It will be very important that you can refer to these. And remember this part, subtract in the exponent and add in the exponent, sometimes helps remember those. Good luck with that.